Okay, so one of the problems was I saw some people missing some of the steps to graphing. So you guys got to make sure you're paying attention. Everybody's paying attention. Um, because we're missing little things. And we're coming up on assessments that are going to be wrapping up this quarter. And if you don't know what you're doing, those grades are going to be plummeting. All right? So the first thing we need to do is make sure there's a title. But sometimes it's a good idea to have our variables in place before we do that. We have to decide. We have two variables on number one here. We've got meal cost and we have tip. And we got to figure out which one we're going to make for the x-axis and which one we're going to put on the y-axis. I told you guys yesterday we have dry mix. Dry, does anybody need this worksheet from yesterday? So dry mix. Dry means dependent variable is the same thing as the responding variable. It goes on the y-axis, but I like dependent using that term. Mix means the manipulated variable, which is also sometimes referred to as the independent, goes on the x-axis. That goes side to side like a xylophone goes side to side. Y is the yo-yo. All right? So if we just ask ourselves, you have a meal cost, so how much food costs, and then you have a tip. Does it make sense to say the meal cost depends on how much the tip is? Or does it make more sense to say the tip depends on how much the food costs? Okay, there are other factors involved, but overall, your tip depends on how much your bill is. A lot of times you figure like 20%. Like if you go out to eat or something, 20% is usually a pretty good tip. I think 10% is a little cheap. 15% might be more like average. 20% means average or slightly above. So the way I do it if I go out to eat is if I've got a $35 bill, okay, what I do is I just move that decimal one spot, it becomes 350. That's 10%. And if I double that, that's 20%. If I were to triple it, it'd be 30%. All right? So that's how I figure out my tips at the table. If it's some weird number like 48.25, I usually just round that up to like 50 bucks. 50 bucks. Move the decimal, that's 5. I give a $10 tip. Okay? So that means the tip is dependent on the meal cost. So the tip is the dependent variable. So which one does that go on? D, dependent, dry, y-axis, right? So I'm going to write that on this side. Anytime I label an axis, I also want to include every single time what? The units. So the tips, they're in dollars. Okay? That means the meal cost is going to go on the X. And that is also in dollars. And we always want to make the origin, we want to make that 0 whenever possible. There could be some crazy times where we can't make the origin 0, 0. Thank you. All right, so we got to figure out our scale for the x-axis here. Can you close that all the way, Isaac? All right, now I saw some people on their graphs yesterday, they were just taking these in order like they were doing a bar graph or something. So they just went on the very first one, meal cost 475. So they just label it like 475 and then it was 50 cents. And they'd mark it wherever. Okay, we can't do that though because we don't have a scale here. We don't know what this means, and we're gonna have dots all over the place and they don't make sense. Okay? We want everything to go in order from like lowest to highest as we go across this x-axis here. All right, so what I want to do is figure out what's the largest value I got to cover And in this case, they give me marks to use, so I also got to keep in mind how many marks I have. So on this bottom going across, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 marks, okay? If I look at my meal cost data going along this line on the top, I see that my highest value is 20.42. So I got to make sure that my x-axis goes at least to 20.42, like it at least goes up to 21 or maybe 22 or 25 or something. All right. So I talked about yesterday, if we think about our place values, like we have ones place, tens place, hundreds, just going kind of backwards. But in terms of numbers that are easy to use, here's a good idea. This is good to keep in mind. Um, Things that go into it, say um, one time or two times or 5 or 10, those are usually good things to use. Like if I was ten's kind of an easy one to, or maybe 100, at 10. All right. So if I gotta go 10, I've got 10 marks or something. It's good to go count by ones. That makes sense because that goes into 10 evenly. Or twos because that goes into 10 evenly. 2, 4, 6, 8, 10. Threes, 3, 6, 9. No, that doesn't work so well. Fours, 4, 8, no. Fives work well because I can just go 5, 10, 6, 7, 8, 9. They don't work so well. Just 10. Okay? So if we pay attention to this, if I, what goes into it 10 times, what goes into it 5 times, what goes into it twice, what goes into it once, if we keep that in mind for each of these spots, these are good values to use when we mark lines. If I'm going to 100, 10 still work. I could also say 20s would work. Um, I could even do 25s go into it evenly. See? 30s, no, not really. 40s, no, not really. 50s work. 100 works. So numbers that go into it evenly are good to use for marks, and they're pretty easy to understand. Okay? Ones, twos, fives, tens, 25s if you're going higher. All right, so anyway, I have 11 marks. So if I made each one worth 1, it would go up to 11. Would that be high enough? No, I got to go at least to 20.42. What if I made each one worth 2? Do you know what 2 times 11 is? 22. So that would be enough. That would go just slightly above 20.42. I don't want to make each one worth 5 because then it's going to go up to 55. I want to go just slightly above the number so that I'm using up as much of the graph as I can. So my scale is going to be by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay? Now we got to figure out the tip side. And the tip side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 there too. All right? So on the tip side, my highest value is 3. Okay? So I've got to get to 3. I have 11 spots to do so. Um, so if I did like 3 divided by 11, or we could just kind of see, like what if we made each spot worth a quarter? Would that be enough? Like if I went 25 cents, 25, 50, 75 cents, a dollar, dollar 25, dollar 50, dollar 75, $2, 2.25, 2.50, 2.75. It doesn't quite reach our $3 mark, so that's not going to work. Again, we don't want to use like 30 cents. That's not one of those that goes into a dollar evenly. 40 cents doesn't really work. Our next option is going to be 50 cents. Now that's probably going to go a little high, but our other option, as far as workable numbers goes, okay, wouldn't have been enough. 25 wouldn't have been enough. So let's do 50 cents. That should work. Now here's another thing, especially as you see on here, I don't have as big of a paper as you guys, and I'm using this thick marker. So it's hard for me to write in numbers. I could do each one mark at 50 cents. You can do each line 50 cents. Or I could do every 2 worth how much? A dollar. Same thing, right? If I numbered each one 50 cents, dollar, I could just skip one and say dollar, $2, $3, $4, $5. Plot our data. So the first one is 475. So I got to figure out where 475 is roughly, right? I know that between 4 and 6, halfway between would be about 5. Pretend that's halfway between. So a little less than 5, which is actually probably where I put my mark, would be about 475. And if I go up to 50 cents on the tip, that's easy. That's the first line. So I'm going to put a dot here, somewhere around there. Okay? The second data point, I got to go to 684. So kind of close to 7. That'd be halfway between. Yeah. Okay, so halfway between 6 and 8, I messed up and did a little less than halfway between 6 and 8 again, which is probably where 6.84 is. And the tip is 90 cents. So here's 50, here's a dollar, halfway would be between, so I'm going to go kind of close to a dollar, maybe about there. Could be a little lower than that. We have 12.52 for meal cost. So halfway between 12 and 14 would be 13. Halfway between 12 and halfway would be 12.50. And then the tip is going to be $1.50. So here's $1.50. So maybe somewhere around here. Okay. And then we got to do 20.42. So kind of the same thing, a quarter of the way past 20. And I got to go to $3. Maybe about there. And 8.97, that's almost 9. It would be a dollar. Okay. And then let's say you get this one customer in there, and even though their bill was only $8, you don't have to, well, this might be a good idea to put on there. Their bill was $8, and yeah, even though their bill was $8, they tipped $5 because they're a super nice person. Okay? So even though their bill was only $8, they tipped $5. So go to 8, go up to 5, put a dot there too. All right? Well, so I mentioned yesterday when you do line graphs, you do dot to dot, all right? And you don't always do that. What we're going to do is we're going to do what's called a best fit line because a best fit line will be a straight line. And from that, we can see relationships. Helps us understand what's going on between the variables, okay? So here's how you do a best fit line. You start by kind of just seeing what's the general trend of my data. What does it seem to be doing? Now, it seems to be going something like, maybe something like this here. And you could trace this on yours and paint on your with pencil or something if you wanted to kind of get a good idea. It kind of seems like it's like this kind of generally. All right, kind of across here, maybe a little more this way. Okay. But that one up there doesn't fit, does it? Doesn't fit that trend. This is what we call an outlier. We have to be able to identify outliers in our data. Sometimes you'll record data from an experiment. It's all like, oh yeah, I can see what's going on here. I can see there's a relationship. Like as this one's going across, it's increasing. And then you get this one weird data point way over here, and you go, what? What was that? And it could just be one bad trial you did where you made a mistake. Okay, like we said, we talked about error and things like that. It happens. All right. So we're not going to use that. And we might want to look back at that trial and try to figure out what happened. Okay, something could be wrong there. So what we do is a best fit line. So I've got this general trend here I've kind of identified. I'm going to go ahead and erase that so I can see my line a little better. If I can do it without erasing my dots. All right. Okay, so what I want to try to do is draw a line that goes along that trend, and I want like half my points above it and half below it. Now, we only have 5 points here, so we can't really do that. But I'm going to try to draw a line, sketch a line right through the middle of that trend. And you want it to be a straight line. You don't want to bend it to make it fit, okay? Kind of maybe go back and forth until you've got this. All right, and that's our best fit line. It should be a straight line. If I could just put a ruler up here and make a straight line through it, that would be much better. And doing graphs in pencil is a good idea because if you put that best fit line on there and you look, oh, yeah, I think I could have did it better. You can always erase and do it again, okay? Does it seem like it's a good representation of a general trend through your data? Okay, half the points above, half the points below. Because here's what we can do now is we can figure out the slope. Now we have a straight line. And when we do a slope, we don't want to pick any of our original data points themselves. We want to just work with the best fit line. We also don't want to use the origin. What I do is I look at my best fit line and I look for any intersections it seems to run directly through, okay? And I start from the very left, all right? Now starting from the very left, actually it seems like it hits the x-axis right between the 2 and the 4. You see that? This point, I'll do it in blue so you can see it. But doesn't it look like it hits the x-axis right between the 2 and the 4? What would that value be? 3. So I'm going to make this my first point. And that point there, I'm going to mark it like this. I put the x value first, which is 3, and I put the y value second. What's the y value there? 0. Okay, so I'm going to use that. And then I'm going to continue along the line. I'm going to look for another intersection that hits. Now, is it possible that your best fit line is different than mine? Is it possible you're going to run through different intersections? Is it possible you're going to have a different slope? Yeah, and that's okay, all right? That's why we say we want to see the general trend, not the exact specific trend. So where else does it hit evenly, nicely? Let's see. These not so much. I guess maybe if it hit here almost. Okay, I'll try to use that point. Forgot something here. This, what I call this, by the way, always going left to right. This is x1 and this is y1. Okay? My next point, so put the x first, is at 16 and $2.50. Okay, so what those points are is x2 and y2. All right, so when we do a slope, this is what we do, and it's written on your paper. Okay, it says for the slope, you do the rise over run, which means you take the y2 and subtract the y1, that's the top part. And on the bottom, you take x2 and subtract x1. Okay? All right, so y2 is 250 minus y1, which is 0. That's going to be easy enough to do. X2 is 16 minus x1 is 3. All right? So the top is just going to be 2.50 over 16 minus 3, which is 13. All right? And that's my slope, 2.50 over 13. Now, that's not really easy to work with. I usually like it to be one of those numbers to be like a 1. Or what I can do is just make it a decimal. You guys have heard of fractions? You know what fractions are, right? Sorry, I'm not a math teacher. I don't know when you do stuff. Um, but what I can do is just treat it like a fraction, which is really just like a division problem. And I can go 250 or 2.5 divided by 13. And it comes out to be 0.192. It's also important to understand what I'm talking about here in terms of units. So when I did the y2 minus y1, that was talking about the tip, all right? And the bottom was talking about the meal cost. So this is really tip over meal cost. This also gives me an idea of what I can title my graph. We don't want to forget the title, which I could call tip versus meal cost or meal cost versus tip. But really what we're talking about here is just tip amount. So we can call it tip amount. All right. And now what this is going to do, if this shows us a relationship, if we look at the next question, if the diner orders a meal costing $10.50, how much tip should the waiter expect to receive? Do you guys have any idea how we might figure that out? Don't think about my 20% rule that I showed you. This is just based on this example. Nathan? Multiply the slope with the meal cost? Is that what you're going to say, Michael? How would we determine if that seems like a good idea? Just think about it and make sense of it. Use it, try it, calculate it, see what happens, see if it makes sense. Why not? You guys, somebody have a phone? Who's always got their phone out here? Get ready with your calculator. All right, so that means take this number that we got, this decimal, this 0.192, and you're going to multiply that by 1050. Is that what we're going to do? That's what you said, Nathan? All right, let's try it. 957. Is that right? $9.57. If I round that off, 2.02. Huh? Yeah, I think something happened there. All right. So expected tip $2.02. Does that make sense? Is that a good tip on $10 bill? What was my rule? If it was me and mine was 10.50, I would probably round it up to like 11. So if I take that 10% would be $1.10. Double that would be 2.20. Maybe I'd give them $2.50, an extra 30 cents. So is that too far off of that? Not bad. What if we checked our best fit line? What if we went there and looked at $10.50? So that would be about here. And we go up to the best fit line. Where does it hit that best fit line? Yeah, about 150. That's off a little bit, isn't it? So my best fit line might be a little crooked. It's okay. All right. But figuring out that slope should give us an idea for the relationship. Okay? Or just using the best fit line to try to figure it out. Maybe somewhere in between. Okay? So what I want you guys to do is I want you to move on. Now we should be able to try to do everything. Title, label the axes with the correct variable on the correct axis, with the correct scale, the data plotted correctly, a best fit line through the middle, figure out the slope, and answer any other questions. Okay? So let's move on to the second graph and try to do all of that. Okay?